Good afternoon. My name is Jean-François Bilodeau. Welcome to the Securing Resources in Microsoft Azure seminar. Once again, welcome. Thank you very much for taking some of your time of your busy day to join us today. A couple of quick things when it comes to the session. Check that you can raise your hand next to your name on the left. I think that applies more to Zoom than to GoToMeeting or GoToTraining that we're using right now. So if you have any questions, don't be shy to drop them in the question window. You can always leave me a message in the chat window. I'll do my best to get to them as we carry along. So ask questions freely as we carry along. Slides and the presentation itself will be available after we're done. We are recording this presentation. So if you want to replay it, rewatch it after we're done, or if you want to share it with others, hey, not a problem. Do take advantage of that as we carry along. So again, the recording will be available to us. Before we jump in, let's talk about what I'm hoping to cover with you guys today. Now, honestly, we're only here for an hour. There's only so much I can cover when it comes to security resources in Azure. I'll do my best to cover a bit of a breadth, but not too shallow either. I am hoping to get into some scenarios, talk about some architecture, some principles when it comes to creating secure solution in Azure, architecting effectively for Azure. But I hope you'll understand that there's only so much that I can go into. I'll try to reserve hopefully ample time at the end of this session so that if some of you have questions, scenarios you want to discuss, I'll try to make some time available for that. But I do want to start with a very quick review of security principles that we are going to discuss as we carry along, and ideally where those principles fit into the Azure equation. We're then going to briefly talk about DevSecOps, because it's hard today to talk security without talking DevOps itself and the importance of integrating the two, moving away from the traditional approach of securing our application by developing, then throwing it as a security team for review, and then making a decision, what do we do with it? So let's integrate that with our process. Following that, we're finally going to jump into Azure Security. All right, some basic principles and understanding compliance that's available to us when it comes to working with Azure. Then I like to take a look at security from 4 different perspectives. Your perspective at this point, talking about architecture and by extension development, getting into deployment of our resources, of our application solutions to Azure, talk about configuring those resources, especially since most of you would assume are working with a combination of dev environment, test environment, prod environment, and maybe a couple more in between. And we want to make sure that we can address distinctions, differences that we are going to encounter between those environments. And let's wrap things up by talking about security in operation. All right, it's one thing to have DevSecOps. It's one thing to ensure that we write code that we assume is secure, but when we operate it, let's ensure that we do 2 things fundamentally. Of course, monitor and respond to any event, and also use that as a feedback loop to continue to improve the security and the value behind our application. So a lot of good things coming up for us, but let's begin with a quick review of 4 security principles over here that most of you, I would assume, are already familiar with. The first one is the importance of authentication. Who are you? Talking about identifying yourself. And in the world of Azure, we actually have a couple of options for that. We can get, well, primarily into Azure AD, Azure Active Directory if you prefer. I do want to emphasize that Azure AD is not on-premise Active Directory. Most of you are probably familiar with Windows Active Directory. Most of you probably use it in your enterprise. And you can extend that to Azure. There's multiple ways by which we can do that, but Azure AD is a different beast. It's an internet-first authentication and in some degree authorization platform that's available for us, identity platform really when it comes to Azure. We'll talk about it as we carry along. But I do want to establish this right now. This is very important. Azure AD is not on-prem Active Directory. We use different protocols. We don't use LDAP with AAD. It provides identity management. It also provides tools for authentication, and we can get into authorization as well, which brings us to the second bullet over here, dealing with once you've established your identity with Azure and by extension the applications themselves, the next step is to determine your authorization. What are you allowed to do? And I can jump kind of sort of to the last bullet over here, principle of least privilege. And I think we all recognize this, that for any identities that are going to participate, roles if you prefer, that will participate in our application, ensure that they have enough privilege that it can achieve what they've set out to achieve. They can complete their use cases, but no more, right? Depending on what their roles are. I'm going to switch over to my pen. There we go. And the last one over here that we're going to talk about is going to be confidentiality. And again, I think we all understand that one, ensuring that as information transits through our system, we can ensure that those that have access to that information, who have the authorization to create, view, modify, erase that information, have the ability to do so. And of course, those that don't, do not. And that's the principle of confidentiality. We'll talk about how Azure deals specifically with that. Before we jump into the world of Azure, brief discussion of DevSecOps. What are we talking about? Well, let's define a couple of things over here before we move ahead. The first thing I want to make sure we understand is the word DevOps. And unfortunately, I find there's a lot of misunderstanding out there in the industry when it comes to what is DevOps. So before we talk about DevSecOps, let's make sure we understand what is DevOps and also what is not DevOps. It's again, unfortunately, I see so much misunderstanding out there. If I can summarize it very briefly as to how we should look at DevOps, one of the principles over here that I think most of us are kind of somewhat aware is the idea of integrating Dev and Ops. But what does that mean, integrating? Well, the way we should see it is not slamming together the Dev and Ops team. It's not the end goal. The end goal ultimately is to ensure that we have a unified development and operation process. It's really at the process level. That's where DevOps comes into play. As a means to an end, yeah, we'll most likely need, and it's highly desirable, to get Dev and Op to work together. In other words, let's eliminate that traditional scenario that most of you are probably familiar with, where you have a silos for development, you have a silo for operation, and you probably have other silos, for example, a silo for testing, maybe a silo for DBA, and of course, let's throw in a silo over here for security. And they all work in isolation of one another. There are more or less established channels of communication, processes as to how they work together, how they can exchange information, but it's not really holistic. We're not looking at the development cycle and operation cycle as a whole. And very often what happens, I find, from siloed environment is that it leads to conflict. It leads to conflict might be too strong of a word over here, but some reticence or some looking for the right word over here, but it doesn't allow the team to see the big picture, what it is we're trying to achieve with our development process, with our operational process. And I do want to emphasize over here a very important point that will fit into DevSecOps. The idea over here is that one cannot exist without the other. What's the point of writing code if there's no operating environment for that code. All right, so I've got this wonderful solution. I can't run it anyway. Zero business value. And the inverse is also true. What's the point of having that wonderful runtime environment in Azure on-prem, wherever, if there's no code to run into that as well, right? So it's important to recognize that really developing code and operating code needs to be one integrated process. And one of the approach that we use to achieve that is the idea of using pipelines, one or more pipeline, typically referred to as CI/CD pipeline. But I do want to emphasize, to eliminate some common misunderstanding over here, is that when we're talking about pipelines, we're talking about a means to an end. Pipelines are not required for DevOps. They're just a means to an end. But what I'm getting at over here, the important point, is that this process over here needs to include security. That little silo that we identified over here, let's get rid of the idea of putting all of security in a silo. Let's integrate them with the process. They're now a participant in the development operation team, right? So let's not have developers writing code, then throw their code at the security team, have them review it and determine whether it's valid or not according to whatever criteria, and then throw it back and forth, manually throw it back and forth. That's not DevOps. That's back to being cyber, the antithesis of DevOps. So what I'm really getting at over here is the important part is that security, development, operation, and everything else, let's not limit it to those three sort of roles over here. Everything else needs to be part of security, right? So you'll see why I'm mentioning this right now. Let's move ahead over here now that we've established what is DevSecOps. Let's put aside development for now and operation, and let's just talk about some characteristics of Azure to assist you when it comes to working with security. Some tools that are available for us over here. The first one over here is the Azure Security Advisor. And chances are, for those of you who have a subscription to Azure, if you crack open your Azure portal, there's a good chance you've seen a pop-up come up suggesting that you either review some advice from Azure. Azure has a number of advice. They scan your architecture and provides advice as to how you can improve it, including from a security perspective. And you also have the Azure Security Advisor, which I would recommend we certainly take a look at, enable within your organization, especially in dev and in prod, to maximize our security. Now, one thing to recognize over here, and actually I'll add that right now to our discussion. Actually, I'll come back to it later on since that'll be part of a slide. But when it comes to security, Azure, Microsoft has its roles and responsibility, but you also have your role and responsibility. And that's something I want to come back to. Understanding where do we draw the line as to who is responsible for what. Another thing that's important over here to recognize, not just from a security perspective, but from a compliance perspective, what is Azure compliant with? Well, if I may go back to, let's crack open. There we go. This page over here, Azure compliance. I'll share that for you in the chat window. For those of you who are interested, there it is. So that's the site I'm looking at over here, the Azure compliance site. This is a list of all certification compliance that Azure meets presently. There's a lot, as you can see over here. I'm not going to go through the whole list over here. I'll let you review that at your leisure, but there's a list of compliance, including some industry-specific compliance over here, security-specific compliance. So to ensure that your application meets regulatory guidelines for your industries, that sort of thing, that's going to be an essential page for us to consider to visit. And finally, another thing I'm going to mention, just as a generality, Azure deals with security by default. Pretty much everything end to end is encrypted in Azure. You've got encryption in flight, you've got encryption at rest. So your data that's sitting on disk in Microsoft Azure and data that is being exchanged, say, between application and Microsoft Azure. If I can expand that a little bit, let's go back over here. What I mean by that over here is if you have, there you go, let's draw an Azure region. So that's one of my Azure region, let's say Canada, Central, US East, it doesn't matter what region over here. So I've got an Azure region and I've got an application running in that region, whatever that application is, and that application needs data that exists in another region or maybe in the same region. Let's say I've got a SQL database over here and the application needs data in that SQL database. Those may exist in two separate racks. It may be even two separate buildings in the Microsoft region, the Microsoft Azure region. However, communication between those two elements will be isolated and encrypted no matter what. If the application needs to talk to, let's say, another service, I've got a microservice over here running in another region. When that application communicates to another region, we are going to go through the pipes that Microsoft has established, typically dedicated pipe, but even though it's dedicated pipe, we still encrypt the data for you. When it comes to the data at rest, for example, my database, my storage account, Cosmo DB, whatever we're using over here, that is also encrypted by default, security by default. If I can kind of show you two examples quickly, I'll go back to my Azure portal over here. I've got a SQL database that I created for a previous demonstration over here. If I may go down to security, transparent data encryption, this is on by default. Yes, I can turn it off, but it is on by default. Another example I'd like to bring up, I've got a storage account over here. Let's crack that open. When it comes to that storage account, there's encryption. It is encrypted. I haven't changed anything over here, but you'll notice over here when it comes to the encryption type, I've got two choices: Microsoft managed keys or customer managed keys. Which one do you want to use? Do you want to use the keys that are provided by Microsoft? But if you want to have a higher level of security, confidentiality, that makes it even more difficult for somebody to acquire your data, you can provide your own key. Now, the caveat to that is because you're providing your own keys, Microsoft's not going to hold on to them, which means that if you lose them, you lose access to your data, right? So be careful when it comes to your key management. But we are going to talk about key management as we carry along. So that's another way by which I can ensure that not only my resources are secure, we know that they're going to be secure by default. We can also add an additional layer over here where we increase the responsibility that we take on to provide, in this case, a higher level of confidentiality. The only time that Azure will allow unencrypted data to exit out of Microsoft Azure is the situation where your app goes on the internet, either through incoming traffic. Let's say I open up a port, I open up an endpoint on the internet to receive incoming communication, incoming traffic, or I go out of the Azure data center on the internet. Well, at this point, it's entirely dependent on which protocol you're using. Assuming that we're dealing with HTTP, are you using raw HTTP, or are you going to use HTTPS secure, of which Microsoft provides certificates for you by default? You can certainly take advantage of that. And if I wanted to increase the security of my application, I might consider disabling HTTP altogether. I can show you how to do that later on, ensuring that traffic will always go through secure channel, in this case, HTTPS, or whatever protocol I may elect to use, but I think we all recognize HTTP or HTTPS is pretty much the de facto in the industry today. So end-to-end encryption, and we can continue to talk about some security principles in Azure, but I'll come back to them with more relevant example. I hinted at, for example, Azure AD for identity management, and we can certainly drop that into some equation as well as other resources that are available to us. But now let's talk about architecture. Not the architecture of Azure itself, but how we're going to architect our application. So if I have any architects in the session today, let's talk about some of the things you might consider when it comes to building a solid security architecture in Azure. Now, I'll warn you right now, this is going to be superficial. Now, it's just enough to kind of sort of get you started, get a sense of what we may need to know when it comes to architecture, but it's not going to make you a security architect. All right, if you want to become a security architect, we'll talk about that later on. But the first thing I want to mention over here is the idea of favoring risk transfer. As an example of that, all right, here's the scenario. You've got your vendor. So in our case, it would be, of course, Microsoft / Azure, or it could be another vendor. Doesn't matter. It doesn't even have to be Microsoft. Could be IBM. Could be Amazon. Could be Google. Could be whoever as our vendor. And we have ourselves. And the idea over here is we are going to take on some risk. No matter what you do, you take on some risk. The moment you start developing and operating a solution, even if it's a cost solution, it's a risk that we take on. And the idea over here is how much risk are we willing to take on? Let me kind of sort of draw it this way over here. It's not as straight as I would like, but we've got risk over here that the vendor agrees to take on, and there's risk where we agree to take on. And the part down here is generally the part that I want to avoid, where I actually end up taking on most of the risk, including security risk. Now, unless in your company's name, you deal with IT and you deal with IT security, chances are risk management, security management is not the purpose of our business. And I do want to emphasize that over here. Risk management, security management, IT security is not what our business is about. I'm not sure which business you come from, which organization you come from. Some of you might, and if you do come from that background, I think you understand where I'm going with this one. What we want to do over here is we want to stay closer to the top over here, where we transition as much of the risk as possible, including security risk, to the vendor. All right. And one way to think about it is that my role as an organization, my mission as an organization isn't to deal with IT security. My role in my organization, or our organization's mission, is to deliver value in the form of whatever. It could be products, it could be supply, it could be financial services. It doesn't matter what it is. It could be federal government, provincial, municipal, doesn't matter. What's important to realize over here is that we're not in the business of managing technical risk. So how are we going to do that? Well, let's get into the idea of the three flavor of cloud that we have. The type of cloud services that will imply the least risk for us, where, pardon me, the vendor is responsible for the majority of risk, is a SaaS-based solution, software as a service. You guys probably know a couple of examples, but things like Office 365 is an example. You could even throw in here Gmail if you wanted to, or Outlook.com. You could drop in, trying to think of other common examples out there. Well, even Azure DevOps, not to be confused with Microsoft Azure. DevOps, which is really TFS rebranded, Team Foundation Server rebranded. These are examples of SaaS. And one of the advantages that we have when it comes to working with SaaS is transfer of risk. It's no longer our responsibility to handle so many risks when it comes to security, identity, authentication, authorization, confidentiality. Those principles that we've talked about, they're still a part that we are responsible for, but the majority of it we transfer to the vendor. Moving down the list, we can get into a part where I don't want to say it's exactly 50-50, but it's a good way to think about it, where we want to move towards a PaaS, platform as a service. Now we're entering the Azure world. You've got, for example, the idea of web apps. You've got, I'm going to include over here Docker. So some people might qualify it as a IaaS. It is close to an IaaS, but I'm going to put it in here nevertheless. We can get into a service like SQL databases or even Cosmo DB and other Azure resources, where at this point we are taking on more risk. And one of the reasons is we are running our own code. We are responsible to ensure that our code is as solid as possible, but then the environment in which our code runs, most of it becomes the responsibility of the vendor. And it's important over here to understand, where does your risk start? Where does your risk end? So that we can draw a good line over here, know what the vendor is responsible for, Azure in our case, know what we are responsible for. And then we can go down to IaaS, of which we'll find things like the virtual machine. Most of you, I'm assuming, are familiar with that. We can get into things like VNet, very essential. We'll talk about those as we carry along. But at this point, we are taking on the majority of our risk. So for the architect in the classroom, I do want to emphasize over here that important idea that from a security perspective, our role as an organization is not that of security. Security is essential. Of course, we need to have a secure solution for a number of good reasons, including, well, financial and, of course, verifying our reputation with the industry, protecting our clients and our users' information. So numerous good reasons. But the idea over here is our role is to deliver value in the form of whatever, meeting our mission as well as possible, not developing security solution. Another thing to consider as well that's very important over here is Microsoft has a huge dedicated security team for Azure that probably puts everything you do in terms of security to shame. And I'm not belittling what you guys are doing. Microsoft is investing hundreds of millions of dollars, if not billions of dollars, in security. Right? How much are you guys investing in security? And again, I'm not trying to belittle what you're doing. I just want us to recognize here that by shifting the responsibility to the vendor, we do accrue at this point a dedicated team, not necessarily dedicated to our application, but a team that is dedicated to security in a way that we'll never be able to achieve with our resources. Again, not trying to belittle us, just recognize the importance over here of ensuring that the resource that we put in security are there because we need to. We're not taking away resources that can be utilized to deliver better business value elsewhere. So that's what I mean over here by favor transfer of risk. Transfer the risk to your vendors, your dedicated vendors who have budgets that far exceeds what we have when it comes to risk management. Another A way to architect your solution to minimize risk is isolating resources from the internet. What do I mean by that? In a nutshell, if I can talk Azure at this point, let's go back to our regions over here. When we create a resource, and it depends on the resource that we create in Azure, but especially traditional Azure resources by default had public endpoint. And it continues to be the case. Things like your SQL Server databases, things like your storage account, your virtual machine have public endpoint. Now, one of the things that we can do with Azure, which is important over here, is we can now disable at least that public endpoint. And for any communication that we're going to need between resources and Azure, resources in Azure, we're going to use VNet and have the resource communicate to one another via VNet in Azure. But what if I need to communicate with on-prem? So here's my on-prem data center over here, and I've got a resource over here. Whatever that resource is, we'll label it as an app for now. Whatever type of app is not important. I do want to ensure that this application is usable on-prem. How do I do that? You've got a couple of options. One option might be to re-enable the public endpoint, but to secure it. For example, I could whitelist some IP addresses. I determine which IP address or addresses will that resource permit. Or I could deal with authentication and authorization. If an on-prem, whatever, needs access to that resource, they're going to go to the public endpoint, throw some credentials at it using technologies like SAS, shared access signature, something that we could consider to allow the application to access the resource. And that's reasonably secure, but one thing to consider is that it's one way, unidirectional. From on-prem, I can consume that application. I can also do that at home, which I think is very important over here. So there's my home over here. Most of you are probably sitting at home right now, and I'm running an application on my system over here. That application needs that resource, while having a public endpoint would permit my application from using it. Some of you may be quite contented with that, but can be made secure. Some may want more control, and there's a couple of options that we could consider at this point. We have a VNet over here, virtual network. One of the things that we can do is we can connect that VNet to our on-premise network over here, our on-premise network over here. And there's two ways by which you could consider doing that. You could do it via VPN. Set up a VPN endpoint, a point-to-point or point-to-site VPN, for those of you who are familiar with that. Or I could set up what we call an express route with Azure, where we would literally connect, create a direct line, a dedicated line between your data center and Azure itself, right? So that we can exchange packets bypassing, if necessary, the internet altogether by using what we call BGP, Border Gateway Protocol, to achieve that. So that might be another option available to us, which would now allow this application, well, those two applications now to exchange packets by going from network to network over here. And now, the fun part is, should I choose to, I can enable two-way communication securely, where now the application running in Azure can now send packets to my application running on-prem. So having bi-directional communication. And if I need to, and most of you are probably well aware of that, if I want this application running at home to access resources in Azure, and of course, resources that may run on-prem, at this point, it might be desirable to set up a VPN between the two. You could, but it's not something I would necessarily recommend. You could consider setting up a VPN gateway, VPN, between Azure and the whole network, but more likely than not, we're just going to VPN directly from home to our on-prem network over here. And from our on-prem network, we can start forwarding traffic to our VNet running in Azure. Another advantage that we have with VNet is something called an NSG, Network Security Group, which allows me to define routing rules. This allows me to determine what kind of traffic can flow in and out of that network, what are the endpoints to my network, what are the routing rules to my network. And just as a last note, for those of you who come from backgrounds where you're accustomed to using Cisco routers, F5s, that sort of thing in your architecture, and you're thinking, gee, it would be really nice if I could use them in Azure. Well, guess what? I can drop in my Azure architecture, say an F5 over here, to mediate traffic between the two networks. Perfectly valid, right? So that's something else we could consider if the necessity was there. And there's other resources we can throw at this architecture. But let's go back to what we're talking about. This really deals with the first, the two bullets over here. Isolate resources from the internet, make them harder to reach from the internet, and control network path using NSGs, using firewalls, using VPNs, express route, whatever you want to use to ensure that traffic packets can flow predictably. And you can use, actually, I'm just going to mention one more tool over here, the Network Watcher. Another Azure resource. One of the things I love about the Network Watcher over here is I can test routes between resources in Azure. Like I said, I've got this IP address, I've got that resource. What route would the packet use to get from resource A to resource B over here? And does it even have access? It will also tell me if access is denied, so I may want to use that as well to verify whether resource A doesn't have access to resource B. So that's your Network Watcher for you. One last thing I'm mentioning over here is IAM, Identity and Access Management, where resources in Azure can be provided an identity. Let me go over, where are you? There you go, access control, identity and access management. I'll talk a little bit more about that when I tackle some specific scenario, but I can use an identity defined in my Azure Active Directory and assign roles to determine who has access to what. And I can use that, of course, to authorize human beings, but be aware I can also use that to authorize application. And that's something I'll come to as we carry along. But let me move to deployment. All right, so you've got this code over here. You've architected it, you've written it, you've got your security team to participate in the development, not just coming after the fact, but participate in the development. So how should we look about deploying that resource, deploying that application? A couple of things to consider from a not just security perspective, but just general best practice, DevOps. First of all, automate deployment. We've talked about that previously, the idea of using CI/CD pipelines over here. Again, CI/CD is a means to an end. Having a pipeline does not make you DevOps, right? If you have an integrated process that is designed collaboratively with a multifunctional cross-disciplinary team, we're probably much closer to DevOps than just having a CI/CD pipeline. Now, the reason why I'm mentioning this is one of the DevOps principle is automation. Deployments should be no big deal when it comes to DevOps. It should not be something that takes weeks, that takes months, lots of planning, lots of headache, working over the weekend, that sort of thing. At first, maybe as we familiarize ourselves with our processes, but we want to strive for long-term value. We want to automate those deployments, whether you do it via pipeline or alternative tool, doesn't matter. One of the reasons why we want to automate deployment and why DevOps one of the pillar of DevOps is automation, is that we're human beings. We're not computers. Computers are able to do, I mean, my cheap mid-end, or what was a mid-end cell phone a couple of years ago, is capable of doing billions of computation in a second, something I'm simply incapable of doing. And I doubt any of us would be capable of doing this unless you're a computer yourself. And congratulations on passing the Turing test if that's the case. But what I'm getting at over here is not only can they do billions of operations per second, they can do it without making mistakes. And whenever a computer does a mistake, 99.999% of the time, it's because of a human mistake. The code is wrong, the configuration is wrong, or it could be the hardware is broken. That could be also another mistake, but usually when hardware fails, the whole thing fails. But most of the time, it's again human error. The reason why I'm getting at over here, what I'm getting at is with automation, favoring automation, automating the repetitive, mindless task is for two reasons. One, let's eliminate the human element. Not only will we get the work done faster, we'll also do it with less mistake. And if there's a mistake that introduces itself, it's probably a human mistake. We've made a mistake in our pipeline, in some to check, in whatever we do over here. And that's okay. We're working DevOps over here, all right? Failure is going to happen. Whether you do DevOps, whether you do waterfall, things are going to go wrong. But let's not kid ourselves. There's no perfect solution out there. The difference over here, the reason why I'm all in favor of DevOps and similar processes is that with DevOps, we recognize from the get-go, yeah, things are going to go wrong. Let's build an environment where when things go wrong, we work towards ensuring that A, we fix it, of course, and B, let's minimize the chance of that happening again without slowing down, artificially slowing down what we do, getting paranoid over what we do, and leading to the waterfall, artificial delay in publishing our resources. Another thing I'm mentioning over here, and that's an Azure specific one, automate deployment. You can do that anywhere. But here I'm talking about ARM template. And I really want to emphasize this one. If you're going to remember only one best practice when it comes to doing deployment in Azure, that's the one over here, ARM template. What the heck is an ARM template? Well, an ARM template, ARM stands for Azure Resource Manager. And an ARM template is a template that's available for you for all resources, including your resource group. Let me go into my resource group. Normally, you'll want to do that at the resource group level. So here I've got a resource group, export template. And an ARM template is a JSON file. It's generated for me by Azure. And the idea over here is the Azure Resource Manager, the component of code in Azure that is responsible for bringing up and down your environment within a resource group, within a subscription, is defined via those templates. So whether you use the portal, whether you use the command list, whether you use the AZ CLI, you use any other tool, it all goes through the Azure Resource Manager. And ultimately, it all goes through template. So as an important best practice over here for security, stability, all those wonderful things, if you haven't already done so, if your team hasn't already done so, grab that template, download it. There's the download button over here. Boom, I've downloaded the template over here. It's actually 2 JSON file. Take ownership of that template. What I'm getting at over here is that template now becomes an integral part of your code. So you've got your Git repository or whatever repository you want to use over here. Strongly encourage you to consider using Git. But at the end of the day, what's important is that you have a versioning system and that ARM template, ARM, if I can spell this, ARM template, now, boom, is side by side with the rest of your code, your C# code, your Java code, your Python code, Node code, whatever you're using over here is not important. It is part of the application code. If we need to change anything in dev, in test, in prod, Let's do it via the template. Edit the template. Right? From a development perspective, before we get accustomed to ARM templates, they're not difficult. They're all documented. Visual Studio Code knows how to parse ARM templates. You've got plugins for that. But what I'm getting at over here is if we need to change anything in our environment, even scale something out. Whoops, our Cosmo DB is not fast enough. Let's scale it out. Not a problem. I'm not going to crack open the console. I'm not going to crack open my Azure portal. I'm not going to start mucking around with the settings in the portal. I'll edit my ARM template, commit it, and push it to my repository. And of course, typically the moment we do that, our pipeline kicks in. Let's say our CD pipeline kicks in. We do deployment. That's the only change that I've done over here. As we go through our test, the test bed, and you can do that with Azure DevOps and other tools as well. The test bed will apply the template itself. So apply the template. So bring any changes in the test environment in line with the template that we've defined over here. And when we push it into CD, into deployment, when we push it to Azure, we're going to apply the same template again. Again, the idea over here is let's maximize predictability. This is the way by which we should deploy our environment. It is now controlled, it is now controlled, it is versioned, it's part of the application. The DevOps team is now owning that template. Let's take advantage of it. So again, if you're not using ARM templates in your application, download them, ensure that the team starts taking advantage of that, takes ownership of those templates. So very important point. Another one that I'm mentioning over here is RBAC, role-based access control, which goes back to the idea of IAM access control over here, as well as your Azure Active Directory, not to be confused with Windows Active Directory, but Azure Active Directory over here, we can define identities. And fundamentally, we'll want to define two flavors of identities: user identities, John and Bob and Mary and Jane and whoever else, as well as program identity, resource identity, all the resources that we have in our application. There you go. Here's my hypothetical, very messy architecture over here. That application now has an identity. That application now has an identity. That database has an identity. And we're going to use those identities, define roles that control what they can and cannot do. And this will provide a number of value, which I'd like to get into over here. So let's start using role-based access control, IAM, to determine not just who has access to what, but which resource has access to what resource. So that's going to bring me to configuration. So nice segue over here, because when it comes to configuring an application, one of the challenge that we have from an automation and security perspective over here is how do we deal with two things? First of all, diverging security or the diverging configuration from environment to environment. I've got my dev environment, I've got my test environment, I've got my prod environment. All of them may have resources like a database. We're not going to use the same database, obviously. And furthermore, we don't want to share the credentials. The credentials that we use in prod are going to stay in prod. The credentials that we use in dev are going to stay in dev, right? We want to minimize credential sharing, minimize the number of eyes that may have access to that. The traditional way to deal with divergent security, diverging credential, certificates, whatever we use from environment to environment, was typically when we package the application. Let's go over here. So I package my application, put it in a little box over here. Boom, that's my application box. Oh, we need to change, say, the connection string for my database. I open the box. So there you go, I've opened the box, reach inside, grab my, say, web.config, make the necessary changes, and then boom, I close the box again, ship it to deployment. I don't like that for a couple of reasons. It's a manual process that, yes, could be automated, but it does imply modifying an artifact. I'm not comfortable modifying an artifact in flight as it's getting ready to be deployed. It implies now that if something goes wrong, now it's harder to determine, is it because the way it's built, is it because the way it's been modified, the way it's been configured, whatever the case may be. It also breaks principles where we want to have one authoritative version of that artifact. So the approach that we typically use today is where instead of modifying files, opening the box, let's scratch this for now. So here's my new deployment over here. We're going to lock it down either logically, or we could even sign it to ensure there's no modification. It doesn't matter. What's important over here is that the configuration that are going to change from environment to environment, we're going to store them in environment variables. Right? Something that all of you are probably familiar to one degree or another. Let me crack that open. For a minute. There we go. Environment variables over here, where I've got, set on Windows, where I've got a series of different environment variables that are specific to the system. I can create my own environment variable. For example, if I do an echo on Windows, it's %. Here, nope. Sorry, more of a Unix guy than a Windows guy. Actually, I'll just switch to Unix, Windows services for Linux. And, oh, I just rebooted my machine, so it might take a moment. Anyway, what I'm getting at, use environment variable. Why? One of the reasons is I can now push configuration to my application without changing the packet. Whether I do that automatically or not, it's not important. Of course, I want to automate things, but it's much easier to automate injecting environment variable. Another really important characteristics of environment variable over here is that they're stored in RAM. If I modify the package, as I'm saying over here, and I throw it on one of my server, and one of my server gets configured, they manage to worm their way to where that application is running. They open up my web.config. Oh, well, here's the connection to the database. I've got everything I need. In the case of environment variables, I'm going to inject them as I start the application. It is written nowhere on disk. It is available only to the RAM in which the application is running. And once the application stops running, poof, they evaporate. They're gone, already reclaimed. So it means that they're much more difficult to acquire than writing configuration to file. So when it comes to configuration over here, store configuration in environment variable. And one last scenario I'd like to discuss with you. What about sensitive information? Right? For example, even if I'm working with environment variable and I've got a nice CI/CD pipeline over here, let's go with this one over here that's going to do deployment, I need to store that information somewhere. For example, what about certificates? If I need to bring up a web service, let's zoom into that scenario over here. I've got a web service, or actually, let's switch that to a microservice over here. Microservice, RESTful microservice, doesn't really matter over here. To operate, that microservice needs a certificate. X509 certificate, or it may need, again, a connection string, but I don't want to store that in a script. Let's say a script to start the application, it's there, plain text, on disk somewhere. Don't like that. I don't want to store it in the pipeline because typically my operation team, my DevOps team, sorry, is going to own the pipeline. No, I don't want to put that in the pipeline either. And it might also be a certificate that needs to be refreshed regularly, say once a week, once a month, whatever the case may be. How do we deal with certificate in a secure fashion? How do we deal with configuration in a secure fashion? Well, food for thought for you. Instead of having a human being, I'll label them as an admin as their role, an administrator generating the certificate on their machine, then copying it over to the microservice, manual process. The certificate exists in multiple places, not happy with that. Let's talk about automating it. Of course, I could create a process, and I'll even propose a pipeline for that, a pipeline that generates a certificate, but that certificate now needs to be pushed to the service. I can't just push it to the service because there's a good chance my service will be transient. It may come up and down, may get updated. So copying it to the disk, no, not a good idea. I don't want to copy it to the disk of the machine that it's running on. So instead, let's use an Azure secret vault. Forgive my terrible handwriting over here. Secret vault in Azure. What is an Azure secret vault? I can show that to you later on. But the idea now is I can use that vault to push sensitive information like a certificate, connection string. All right, so once again, here's my X509 certificate. I'm going to put it in a secret vault. So it's a highly secure storage that's available for you in Azure. You've got two flavors, standard HSM. Standard, it is highly encrypted on disk in isolation. HSM, we're using a hardware security module. So fundamentally a drive that is heavily locked down, that is tamper-proof against attack. So we can use a secure vault over here, secret vault, to drop our secrets in them. All right, for example, I can use that pipeline. I can even set up a schedule trigger so that it runs every week, a weekly trigger over here. Let's say Friday, Sunday, we're going to run that pipeline, have the pipeline generate the certificate, drop it in the vault, and the microservice, when it comes up or whenever, can retrieve that certificate from that vault. Now, some of you might be thinking, okay, JF, that's kind of nice, but what is going to stop, using a min over here as an example, but what is going to stop a potentially malicious user to take a brew in my secret vault? Well, to protect against that, let's go back to some principles that we've discussed previously. I'm going to give my pipeline an identity. Identity and access management. That identity will have write access to the vault. So whatever identity the pipeline is running under can write to the vault, but not read back. My microservice over here has its own identity, but this one has read access to the vault. Can read information, cannot modify information. Who else has the ability to write to the vault, read to the vault in an ideal security scenario? Nobody else. All right, this would allow us to create strongly secret information. Even if Joe and Min over here needs to push a secret, let's say we need to update a secret configuration file, we're going to push it in a vault. Let's not do that manually. Let's throw the file at a pipeline similar to what we have over here, a process of some kind, and have the pipeline write it to the vault. Not the other way around, not the human being, but have an automated process to do that. So to start winding things down, I recognize we're getting close to the end of the session. When it comes to now operating your application, I'm hoping that at this point, we've got a sense of some of the security architecture techniques that are pretty much par for the course for the industry today, and how they would apply to us in Azure. We can monitor resources. We can set up alerts. If I can go back to my portal over here, I'll go back to my demo storage account, scroll down. There's my monitoring. I can set up alert. I can set up metrics over here, have workbook to do analysis. So let's take advantage of those in real time. You may want to use Stream Analytics. That's another Azure resource. Stream Analytics that can do real-time analytics of all events going through your Azure and connect that to alert, connect that to functions, to logic app, to respond to those, to events, or to any unorthodox access to our resources we might encounter out there. So in operation, this environment monitoring and getting into IDS, IPS as well, certainly something we could talk about, is something that needs to be developed and designed in the same scenario we're talking about over here in a collaborative DevSecOps. This is not something that can be defined in isolation. But now I do recognize the time. Oh my God, it's already 1 o'clock. I know some of you are exceeding the time for your presentation. So let me start to wind things down at this point. I just want to leave it at that. That's what the Lord that I like. But for those of you who want more detail, I do apologize, it's only 1 hour. There's only so much I can cover for you guys. I certainly hope that I've delivered some food for thought when it comes to getting you started with using Azure effectively, using the cloud effectively. Also, hopefully giving you some confidence that it's certainly possible to create secure application in the cloud, as secure, if not even more so, than what we have on premise. But the Microsoft course, for what we've discussed over here, would be the AZ 500. It's actually a newer course by Microsoft, the Microsoft Azure Security Technology Training. And there's an, actually, I'll just crack open that page as well for you guys, share with you the link from Web Age Solution, AZ 500. Put that for you guys in the chat window. Here's the link to all of our Azure courses, including the Azure Security over here, the Azure Security Engineer. It is a certification course. There is an exam associated with it. The exam would be written on your own after the course is done. The course does not come with exam voucher. You don't need to write the exam, but for those of you who want to take your skills to the next level when it comes to creating secure application, that would be one that I would strongly recommend. Another one that I like to recommend as well is the Azure Architect technology, which also deals heavily with what we've covered over here. So this said, lots of good ground. Thank you very much for joining us over here. I'd like to reserve the remaining time for any questions you guys might have, any scenarios you want to discuss. Once you've had your fill, you've got what you came to get today, there's one more thing I would appreciate if you could do for me, and that's the evaluation. All right, if there's any feedback you'd like to provide, I'll leave you with our evaluation link right in here in the chat window. You will need a course code, class code. I'll also put that in the chat window. There it is. So you're welcome to drop us an evaluation. If you guys have any additional questions for me, stick around. Otherwise, well, once again, thank you so much for joining me today. I'm hoping that, well, of course, we met your need. Hopefully, we'll see you again in another free seminar or another course from Web Age. And this said, again, I'll deem the seminar officially over, but I'm not kicking you guys out. For those of you who have more questions, stick around. Otherwise, hope all of you have a fantastic afternoon. Stay safe, stay healthy, especially in the current climate that we have.